Every morning, more than 57 million households across the United States do the same thing. They walk outside, fill a feeder, and wait. It's one of the most popular ways Americans interact with wildlife, and collectively, they spend over $4 billion a year doing it. That's more than the entire National Park Service budget. All of it poured into sunflower seeds, suet cakes, and little plastic tubes of sugar water. But here's the part almost nobody talks about. Every time you fill that feeder, you're not just feeding birds. You're running an experiment, an uncontrolled, continent-wide experiment on wild animal populations, and nobody fully understands what the results are going to be. Ornithologist Bruce Beeler, a research associate with the Smithsonian's National Museum of Natural History, put it bluntly. He called backyard bird feeding a massive unintentional experiment being practiced on the nation's wildlife. And very few scientists, he said, are looking at the results. That's what this video is about. Not whether bird feeding is good or bad, because the answer is far too complicated for a simple verdict. This is about what's actually happening out there in backyards and forests and migration corridors because of those feeders. The science is stranger, messier, and more fascinating than you'd expect. Let's start with the good news, because there's plenty of it. In 2015, a team of researchers led by Todd Wilcoxon at Millikin University published one of the most comprehensive studies ever conducted on feeder birds. From spring 2011 to spring 2014, they captured and tested wild birds at forested sites with and without feeders. They measured everything from body condition to stress hormones, antioxidant levels, immune function, and disease markers. What they found at feeder sites surprised even them. Birds with access to supplemental food showed significantly lower physiological stress. The measurement they used is called the heterophil to lymphocyte ratio, and it's one of the most reliable indicators of chronic stress in birds. At feeder sites, those ratios were consistently lower. A constant, predictable food source, even one that only supplemented the natural diet, allowed birds to invest energy in maintaining their bodies rather than burning it all on the desperate daily search for calories. That wasn't the only benefit. At least 3 separate studies have demonstrated measurable nutritional and reproductive advantages for species like blue jays, black-capped chickadees, and tufted titmice living in neighborhoods with plenty of feeders. These birds weren't just surviving. They were thriving. Better body condition, stronger immune markers, more successful breeding seasons. Earlier research, going back to 1981, had already shown that supplemental feeding improved overwinter survival in certain species. A study by Jansen, Ekman, and von Bromsen demonstrated that birds with reliable winter food sources had measurably higher survival rates through the coldest months. And that makes intuitive sense. Winter is the bottleneck. Every calorie counts. A feeder full of black oil sunflower seeds can be the difference between a bird that makes it to March and one that doesn't. But improved survival is only part of the picture. Because when you keep more birds alive through winter, you change what happens in spring. Researchers like Renee Fisher and Scott Miller documented how sustained feeding has contributed to population increases in multiple species. Cardinals, once a primarily southern bird, have pushed their range steadily northward. Carolina wrens, a species that historically struggled with harsh northern winters, now breed in areas that would have killed them a generation ago. The United States Fish and Wildlife Service has noted that bird feeders are a contributing factor in these range expansions, quietly redrawing the map of American bird life. But there's one range expansion that stands above all the others, and it involves a bird weighing less than a nickel. The Anna's hummingbird used to live in one place, Baja California, sun-drenched, warm, predictable. That was the species' home range for thousands of years. Then, sometime in the mid-20th century, something changed. In 2017, researchers at Cornell, led by Ethan Gregg, published a landmark study in the Proceedings of the Royal Society using 17 years of data from the citizen science program Project Feeder Watch. What they documented was extraordinary. Anna's hummingbirds had expanded their winter range more than 700 kilometers northward in just 2 decades. They were showing up in Oregon, Washington, British Columbia, and eventually as far north as Southeast Alaska. For years, the assumption was that eucalyptus plantations introduced in California during the 1930s provided winter blooms that fueled the expansion. But Gregg's team found something different. The hummingbirds in the expanded northern range were significantly more likely to visit artificial nectar feeders than those in the historical range. And the expansion itself mirrored a corresponding increase in the number of people putting out hummingbird feeders in those northern areas. It was a feedback loop. People saw hummingbirds, so they hung feeders. More feeders meant more hummingbirds could survive the winter. More hummingbirds meant more people noticed them, which meant more people hung feeders. The cycle repeated year after year, pushing the species further north than it had ever been in recorded history. Then in 2026, scientists at the University of California, Berkeley took it a step further. They examined museum specimens of Anna's hummingbirds spanning over a century and discovered that the birds weren't just moving, they were changing. Males in the expanded range were developing sleeker, sharper beaks, likely an adaptation to increased competition at artificial feeders. The feeders weren't just relocating the species, they were reshaping its body. So bird feeders can save lives, boost populations, expand ranges, and even alter the physical evolution of a species. That sounds like an unqualified win. But this is where the story gets complicated. Because that same feeder in your backyard, the one helping the chickadees and the hummingbirds, is also doing something else entirely. It's creating a meeting point. And in nature, meeting points have consequences. In February of 1994, backyard birdwatchers in the suburbs of Washington, D.C. started reporting something strange to Project Feeder Watch. House finches at their feeders had swollen, red, crusty eyes. Some could barely see. Others were completely blind, sitting on feeder perches with their eyes sealed shut, unable to fly. Within months, Cornell University researchers identified the cause. It was Mycoplasma gallisepticum, a bacterium previously known to infect commercial poultry. Somehow, it had made an unexpected cross-species leap into wild house finches, and it was spreading fast. The disease became known as house finch eye disease, and it swept across the eastern United States like wildfire. Over the following 2.5 decades, Cornell tracked the epidemic across the country, and what they learned had direct implications for every person with a bird feeder. In 2015, a research team from Virginia Tech, led by James Adelman, fitted wild flocks of house finches with radio transmitters to track their movements. They discovered that the birds visiting feeders most frequently were the most likely to contract and transmit the disease. The feeders weren't causing the infection, but they were concentrating it. Sick birds lingered at feeders because they were too weak to forage normally. Healthy birds fed alongside them, picking up bacteria from contaminated perching surfaces and seed ports. House finch eye disease wasn't the only pathogen making its way through feeder networks. Salmonella enterica, a bacterium that spreads through fecal contamination of food and water, has been found on roughly 7% of feeding structures examined in studies. Pine siskins are especially vulnerable. During eruption years, when these northern finches travel south in large numbers after exhausting their food supply, they descend on backyard feeders in enormous flocks. A single contaminated feeder can trigger an outbreak that kills thousands. Then there's trichomoniasis, caused by a protozoan parasite. Since the mid-2000s, European greenfinches and common chaffinches have suffered severe epidemics linked to Trichomonas gallinae, with garden bird feeders frequently cited as the transmission pathway. Aspergillosis, a fungal infection. Avian pox, a virus. The list of diseases that spread more efficiently at feeding stations keeps growing. The pattern is consistent across all of them. Feeders concentrate birds in artificial densities that rarely occur in nature. They create shared surfaces that accumulate pathogens. And they attract weakened birds that might otherwise disperse, keeping them in contact with healthy populations longer than they naturally would be. Cornell's own assessment offered a surprisingly measured take. They noted that disease transmission at feeders may not be measurably greater than transmission in the wild, since species like house finches and pine siskins are naturally social and would aggregate regardless. Most close observation of these species happens at feeders, which means feeder watchers are simply more likely to notice sick birds. But they also acknowledge that poorly maintained feeders can absolutely accelerate outbreaks. And disease isn't the only threat feeders amplify. There's a predator equation that most backyard birders don't think about until they see it happen. Feeders gather prey. Predictable concentrations of prey attract predators. This is basic ecology, and it plays out in backyards every single day. Cooper's hawks and sharp-shinned hawks, both accipiters built specifically for hunting small birds in tight spaces, have learned to patrol feeders the way a patrol car works a beat. They know where the birds will be, and they know when. The United States Fish and Wildlife Service has noted that some normally migratory hawks have stopped migrating altogether because feeders provide enough year-round prey to make the trip unnecessary. The feeders aren't just feeding songbirds. They're restructuring predator behavior. A European ecology study found that bird feeders attracting more small birds also attracted significantly more sparrowhawks and feral cats, regardless of whether the feeders actually dispensed food. The concentration of prey was the draw, not the seed itself. And then there are the cats. Cats kill more than 2.5 billion birds every year in the United States and Canada alone. That number comes from peer-reviewed research, and it makes free-roaming cats one of the single largest human-caused sources of bird mortality on the continent. Bird feeders, by design, lure birds into yards where cats may be present. A Virginia Tech study found that people who noticed cats near their feeders tended to react with anger and take action, moving feeders or chasing cats away. Hawks, on the other hand, prompted a very different emotional response. About half of feeder watchers found hawks interesting, sometimes even awe-inspiring. The native predator got admiration, the introduced one got hostility, but both are killing birds at your feeder. The only difference is whether you mind. Then there are the windows. Birds flying to and from feeders, especially those flushed by a diving hawk, crash into glass at alarming rates. Research has shown that windows positioned 15 to 30 feet from a feeder pose the greatest hazard, closer than 3 feet, and the birds haven't built up enough speed for a fatal impact. Farther than 30 feet, and they've got time to register the obstacle. But in that deadly middle zone, the combination of panic, momentum, and reflected sky is lethal. With wild bird populations in the United States and Canada already down by nearly a third since 1970, according to a sweeping analysis published in the journal Science, every additional source of mortality matters. So what does all of this add up to? Is the $4 billion backyard feeding industry helping birds or hurting them? The honest answer is both, simultaneously. And the ratio depends almost entirely on how you do it. Here's what the research actually supports. Feeders provide meaningful benefits during winter, particularly for resident species that don't migrate. The caloric subsidy reduces stress, improves body condition, and increases overwinter survival. For some species, feeders have contributed to population growth and range expansion that wouldn't have occurred otherwise. But feeders also concentrate disease, attract predators, and create window strike hazards. Poorly maintained feeders, ones that are cleaned rarely or never, where old seed piles up on the ground beneath them, those are significantly worse than no feeders at all. The data from Project FeederWatch, one of the longest-running citizen science programs in the world, with more than 25,000 participants, tells a more nuanced story than either the feeding industry or the anti-feeding critics want to admit. People who feed birds become more observant of the natural world. They notice seasonal patterns, track species diversity, report unusual events. Ashley Dayer at Virginia Tech found that feeder watchers prioritized natural factors like cold weather over personal convenience when deciding how much to feed. They paid attention, and when they saw problems, whether it was sick birds, predators, or signs of disease, most of them took action. That matters, because the way people respond to what they observe at their feeders can either amplify or mitigate the negative effects of feeding. Taking feeders down during disease outbreaks, cleaning them monthly with a dilute bleach solution, keeping cats indoors, positioning feeders to minimize window strikes. These aren't minor adjustments. They're the difference between a feeder that supports bird populations and one that undermines them. There's also a dimension to this that rarely gets discussed, and that's the supply chain behind the birdseed itself. Many popular feed ingredients, sunflower seeds and corn in particular, are grown using neonicotinoid pesticides. These insecticides are highly toxic to pollinators and have been linked to declines in insect-eating bird species because they wipe out the natural food sources those birds depend on. The irony is sharp. You fill a feeder to help birds, while the seed in that feeder was grown in a way that's killing them somewhere else. Choosing pesticide-free or ethically grown birdseed is one way to address this, though very few consumers think about it. The label on a bag of sunflower seeds doesn't tell you what was sprayed on the field where it grew. David Mizejewski, a naturalist for the National Wildlife Federation, summed up the obligation simply. If you put up a feeder, he said, you must commit to making sure you're not harming birds. That means regular cleaning. That means keeping cats inside. That means paying attention, not just to the birds that show up, but to the ones that show up sick. Because what's happening at your feeder isn't a simple transaction. It's not coins in a slot, seeds for songbirds, beauty for breakfast. It's an intervention in a system that's been running for millions of years. An intervention made by 57 million households, $4 billion, and an almost universal desire to do something kind for the birds outside the kitchen window. The birds didn't ask for any of this, but they're adapting to it. Hummingbirds are changing the shape of their beaks. Cardinals are breeding in places they've never been. House finches are passing diseases they never had before. Feeders brought them together in numbers that nature never intended. Whether that experiment ends well depends entirely on how seriously the experimenters take their responsibility. The feeder is easy. What comes after it is the hard part.